Hey, geometry students, in this lesson, we're going to be talking about angles exterior to circles. And actually, this lesson, lesson 79, is a partner lesson to a lesson from a while ago, lesson 64, where we learned about angles interior to circles. And an interior angle to a circle would be something like if we look at this circle here, HEG, where we have endpoints of our angle, and the vertex are all on the circle. Could also be something like DEH, where we have a tangent to the circle. Okay, like DF would be a tangent to the circle. DEH would be an angle between a tangent and a chord. And way back in lesson 64, I'm going to give you a little refresher. We learned that whenever you have a tangent to a circle and a chord on the circle, making an angle with each other, the measure of that angle is equal to 1/2 the measure of the arc that subtends that angle. Now, remember that word subtend was a really weird word that we first learned back in lesson 64. Subtend just means that the arc has its endpoint somewhere on the angle. Okay. Now, the reason I'm bringing all this up is because we're going to be using that partner lesson information for letter A in just a bit. But let's take a look at Theorem 79.1 to see what we're going to be doing for the majority of this lesson. We're going to learn about angles exterior to circles. Okay, so an exterior angle is an angle whose vertex is outside the circle. But notice that this angle intersects the circle. So we would say that this is an angle that's exterior to this circle. Okay. And the measure of the angle whose vertex is outside a circle is equal to half the difference of the intercepted arcs. So what I'd have to do is figure out what arc CE is in degrees, what arc BD is in degrees. I would have to subtract those two arcs, the value of arc BD from arc CE, okay, and then multiply by 1/2. That gives me the measure of BAD. Now, let's talk about how we can prove that that's the case. We're going to be taking a look at one particular case in which Theorem 79.1 is true. In this case, notice that we have tangents, two tangents, that are making an external angle. Okay, so we could have an external angle like we see in this diagram up here, where these are both secants to the circle. They intersect the circle at more than one point. Or we could have a case where we just have two tangents to the circle like this. And that's what we're going to be proving. So we need to prove that given tangents FE and FG, the measure of angle F is 1/2 the measure of EHG minus EG. Okay, those are my two intercepted arcs. EHG is the major arc, but notice I'm also intercepting the minor arc, EG. And I need to subtract those two, then divide by 2. Okay, let's see how we can prove that. Now, we're going to do this in the form of a paragraph proof. And we're going to reference some things that we learned about in the past. We're just going to type out the basics of our paragraph proof up here. And the first thing we need to do in any proof is list our givens. So we're going to say given tangents FE and FG to a circle with an external angle, EFG. Okay, so I can see in my drawing that I have a circle with external angle EFG. So that's part of my givens. And then anything that's listed as a given, other than what's in the diagram, is also a given. All right, now what are we going to say about this? Let's see. The first thing I'm going to do is I'm going to draw EG. Okay, and I'm actually going to do that. I'm going to draw EG because we're actually going to need this in our diagram to make sense of things. But I'm going to make it a different color so that it just sort of emphasizes that I added this later on my own. Okay, so there's EG. Now, we're going to consider triangle EFG for a moment. And I just want you to think, have we learned about like an exterior angle to a triangle? So is there anything I could say about angle DEG or angle EG? And then if I had a point out here? Well, remember we learned that if you have an exterior angle to a triangle, the exterior angle is equal to the sum of the two remote interior angles. You should remember that from homework problems you've been doing all along. So DEG equals EFG plus FGE. I'm just going to write that out. I'm going to be a little bit fast and loose with the symbols that I use. So I'm going to use this as my angle symbol just because it's easy to use. So what we're going to say is by the exterior angle theorem. That's the one that we're using. Exterior angle theorem, angle DEG is equal to the measure, and I should say the measure of angle DEG. That's the correct way to use the exterior angle theorem. All right, so measure of DEG is equal to the measure of EFG. That's one of my remote interior angles, plus the measure of EGF. Okay, that's my other remote interior angle. Or by the subtraction property of equality, what I'm going to do is from this, I am going to subtract angle EGF from both sides of this equation. Angle EGF from both sides of this equation. That's going to give me the measure of angle EFG. Hey, that's the one we're looking for. We're looking for the measure of EFG. That's going to be equal to, and going back up here to the subtraction property of equality, measure of DEG minus the measure of EGF. Okay. So all I did was I wrote this relationship from the exterior angle theorem, and then I used the subtraction property of equality to get EFG on a side by itself. Now we're going to have to go back to theorem 64 from lesson 64, theorem 64.1, which stated, so we're going to say, according to theorem 64.1, and if you need to go back and look that up, you may. It's one I mentioned at the very beginning of this video. The measure of an angle formed by a tangent and a chord of a circle is equal to 1/2 the measure of the intercepted arc. So in this case, what we would say is that the measure of angle DEG, okay, so that's this angle here, the measure of angle DEG. Notice that this is a chord connected to a tangent. So we have this exact situation going on, a tangent and a chord. This has to be equal to 1/2 the measure of the intercepted arc. So that's going to be equals 1/2 the measure of EHG as the intercepted arc. So we're going to say arc. I'm just going to use a parenthesis to show the arc symbol, EHG. Okay, and there we go. So we're going to use substitution here. So I'm going to say by substitution. And what we're going to do is we're going to plug in. Okay, so remember, what we're looking for is the measure of angle EFG. So I don't want to substitute that up. The measure of angle EFG equals, and I don't want the measure of DEG in my answer. So what I'm going to say here is I'm going to just substitute DEG with 1/2 the measure of arc EHG. Okay, and then I still have this up here minus the measure of angle EGF. Okay, so let's just take stock of where we are. So we have the measure of angle EFG, which is what we're looking for, is equal to 1/2 the measure of arc EHG. That's the arc subtended by angle DEG. Notice that it's internal to that angle, right? Minus the measure of angle EGF. Well, EGF is not in the theorem. I need the angle to be equal to two arcs, 1/2 of one arc minus another arc. So right now, I don't. This last thing is the thing that doesn't work. EGF. Okay, so let's just consider EGF. Wait a second. Do we have here with EGF another chord that is part of an angle with a tangent? We do. So I can do the exact same logic that we did with DEG now with EGF. So the way that this is going to work, just like we did up here, we're going to go back to where we were talking about theorem 64.1. So also, according to theorem 64.1, we're going to say the measure of angle EGF equals 1/2 the measure of the subtended arc. This is going to be the measure of arc EG. Then one more time, we're going to be using substitution. So again, by substitution, the measure of angle EFG, which is again exactly what we're looking for, equals 1/2 the measure of arc EHG. That's what we established before. But remember, before we had minus the measure of an angle EGF. Now I can substitute the measure of angle EGF with 1/2 the measure of arc EG. Okay, so theorem 64.1 really carried a lot of weight here. Now, finally, I'm going to factor, and when I factor something out, I'm really doing it by the distributive property of equality. So by the distributive property, the measure of angle EFG equals 1/2 times the measure of arc EHG minus the measure of arc EG. And that is what I was trying to prove. I needed to prove that 1/2 the measure of angle F, which is the same as EFG, right? The middle one is the one that matters, is equal to 1/2 the measure of arc EHG. I have that minus the measure of arc EG. I have completed my proof. We're ready to move on to some of the actual problems from this lesson.